very good morning to Dr. Loh and Madam Ain. My name is Muhammad Aziz bin Zaidudi. Today I will explain you about my final year project. The title is Analysis of Firefly Algorithm towards Multimodal Problem and Application on 4-bar Truss Structure Problem. Overview of project. The truss structure main component on build-up house, buildings, bridge and many more. Firefly algorithm is one materialistic algorithm that mimics Firefly movement. Nowadays, researchers focus on implement Firefly algorithm in truss structure. Problem statement. An architect and engineer have seen that there are difficulties and inconvenience for their worker on build up the whole structure, especially on frame building. To construct the frame building, they need a truss bar. The truss bar are very heavy due to the wider cross-sectional area. Because of the cross-sectional area are wider, the force that exerted itself are very high. Therefore, reduce the lifespan beam structure. And besides that, it also limits the transportation of truss bar from one place to another. So our objective on this project is to study on Firefly algorithm that implement in truss structure. Second is apply the Firefly algorithm on multimodal problems and 4-bar truss structure. And lastly, to analyze the performance of Firefly algorithm on multimodal and 4-bar truss structure problem. Literature review. Truss structure. Truss structure is a triangulated system of straight interconnected structural elements. In this slide, there are two pictures that show truss structure and not truss structure. The difference between these two pictures is the truss structure have a frame structure which is the advantages is it can hold more load than not truss structure. For not truss structure that doesn't have frame structure, it will easily bend because of the load that apply on it are not equally same. There are 4 types of truss structure which are product truss, fin truss, hole truss and X truss. Optimization. Optimization is one of main research related issue. Parameter that have been optimized called design variable. There are 2 types of optimization. First is single objective where it focuses on single objective design variable for optimization. Main is to find the best solution either maximize or minimize value of design variable. And second is multi-objective optimization where it combines 2 or more different of single objective. These are unimodal optimization where it's a branch of optimization that gives one possible answer in the minimal value or maximum value of function. Figure 9 is the example for the unimodal optimization. This is a 3D graph. Even though we try to change the graph into more than 3 dimension or until 100 dimension, the graph will show the only one exact value or the best value. Differ from the multimodal optimization where multimodal optimization is a branch of optimization that have a multiple answer. These are figure 10 and figure 11 show the example of the multimodal optimization. Figure 10 show the 3D graph where we can see that there are only one value at the figure 10, but when we increase the dimension to more than 3 dimensions, we can see that at figure 11 there are many possible answers. Bio-inspired algorithm. There are many meta-heuristic algorithms that be researched by researchers. First is invasive weed algorithm where it stimulates natural behavior and survival weed suitable for growth, reproduce and colonize the area. Second is Firefly algorithm. It mimics the natural phenomena of Firefly behavior. Third is particle swarm optimization, inspired from swarm behavior such as bird flocking and schooling in nature. Fourth is genetic algorithm, reflect the process of natural selection where the fittest individuals are selected for reproduction in order to produce offspring of the next generation. And lastly, bat algorithm, it mimics the bat behavior. In this project, I will use a Firefly algorithm to implement it into 4-bar truss structure problem and also multimodal problem. Methodology. These are the parameters that have been used in Firefly algorithm. There are 2 equations that have been used, which are attractiveness and the distance of 2 Firefly. These are the list of the parameters for the truss structure. This is also the project model for the 4-bar truss structure design. And lastly, these are the Firefly algorithm flowchart that we use for the multimodal problems and also 4-bar truss structure problem. Result and discussion. Figure 14 show multimodal graph view from the top. In order to achieve this graph, we set into 4 equal maxima and unique global minimum at x-axis is equal to 0 and y-axis is equal to 0. Then we set the algorithm parameter where the number of Firefly n is equal to 25, iteration is equal to 20, and bound is 1.5 and randomization coefficient is 0.05. Figure 15 shows the multimodal graph view from below. As we can see, the red point that shown in this graph is the amount of the number of fireflies. If we set n is equal to 25, the number that enter this graph must have 25 firefly. The firefly spread during initialization and the firefly cover almost all the space. The closer the firefly toward orange circle, it shows the best answer for the optimization. Because of I don't know the best answer for the optimization, I try to change their parameter in order to find the best answer for multimodal problem. First, I will change the number of the firefly. This is the graph that I set 4 different number of firefly. As we can see, I choose n is equal to 25 as an ideal because if we set n is equal to 50 and n is equal to 100, we don't know the movement of the firefly. N is equal to 25, we can see how the firefly move from one place to another. Second is I will change the value of when bound. When bound is the starting point for firefly to move. In this section, we must set the value of when bound into a random value because we don't know the exact value for the starting point of the firefly. Therefore, I will try set when bound to 0.5, 0.8, 1.2 and 2.0. For the analysis is I will choose 0.8 as the ideal when bound parameter because from 4 graph it shows that 0.8 have 56%, which is higher percentage of number of firefly that entering the orange circle other than 3 when bound value. Third is I will change the value of iteration, where the iteration I set it into 20 iteration, 50 iteration, 100 iteration and 500 iteration. From the analysis, we can see that 20 iteration and 100 iteration have the same percentage, which is 76%. But I choose 20 as the ideal because it can save more time than set the iteration into 100 iteration. Lastly, I change the randomization coefficient parameter where I set it first it's 0.01, second is 0.05, third is 0.2 and lastly is 0.5. From the analysis, the ideal value of randomization coefficient parameter is 0.01 because it shows that it has higher percentage, which is 80% number of firefly that entering the orange number. Therefore, the value that being recorded is the best answer on the other parameter. So the conclusion is on figure 32 show that the best answer for the multimodal problem where we set the number of firefly n is equal to 25, the when bound is equal to 0.5, the iteration is equal to 20 and the randomization coefficient is 0.01. These are the best answer for the multimodal problem. Figure 33 show the 4-bar truss structure graph. In order to achieve this graph, we set the parameter where the value of n Pareto is equal to 100, number of firefly n is equal to 30 and iteration it met is 100. This is the benchmark graph. The orange indicator show the reject value while the blue indicator show the possible value or the best value. Because of I don't know the possible answer or the best value for this 4-bar truss structure problem, I try to change the algorithm parameter where first I will change the number of firefly. There are 4 graphs which is n is equal to 10, n is equal to 35, n is equal to 50 and n is equal to 100. From the analysis, the ideal parameter for number of firefly is n is equal to 25 because the graph is exactly same with the benchmark and also give the best answer when compared with the graph at n is equal to 10. Second, I will change the iteration parameter. There are 4 values that I set, which is First, it max is equal to 100, second is 50, third is 75, and lastly is 100. From the analysis, the ideal iteration parameter is equal to 100. Even though the graph for 50 iteration and 75 iteration have approached with the benchmark graph, after I compare with 3 graphs which are 50, 75 and 100, the best answer is iteration is equal to 100. And lastly, I will change the number of Pareto. There are 5 value of Pareto that I said, which are N Pareto is equal to 10, N Pareto is 25, N Pareto is equal to 50, N Pareto is equal to 70, and lastly N Pareto is equal to 100. These are the graph. This is a 4-bar truss structure for different Pareto. The blue one is N Pareto is equal to 100. Orange is N Pareto is equal to 10. Gray is N Pareto is equal to 25. Yellow is N Pareto is equal to 50. And red is N Pareto is equal to 70. From the analysis, the blue line graph or N Pareto is equal to 100 show that there are 47 points that align with the benchmark graph, which is 47%. I choose the N Pareto is equal to 100 as an ideal because the point that align with the benchmark are higher than other than 4 graph. Even though the yellow indicator N Pareto is equal to 50 have the highest percentage, but the number of points that align with the benchmark graph is only 24. Is lower than the blue line graph, which is 47 points that align with the benchmark graph. Therefore, figure 49 shows the best answer for the 4-bar truss structure, where we set the number of Firefly N is equal to 25, the iteration itmax is equal to 100, and the number of Pareto is 100. For the future work for this project is can improve standard Firefly algorithm and implement it into truss optimization. Second is can apply multi-objective optimization on 10 bar or 25 or 75 bar truss structure problem. And lastly, can analyze the performance of truss optimization between standard Firefly algorithm with improved Firefly algorithm. That's all for me. Thank you very much.